This video talks about deciding how to analyse your questionnaire data. It's part of the Managing Questionnaire Data in SPSS workshop. And if you want to have a look at the examples we're using in the video, you can go to the VLE where you found this video. And on the slides, you've got 3 links there to the questionnaires we're going to be talking about. Every questionnaire is really unique. And whenever someone shows me a questionnaire, I can think of a huge number of ways that that questionnaire could be analysed. And that's really overwhelming for people when they're trying to decide how to analyse it. My advice is that you want to plan what analyses you will do before you collect the data. That saves a lot of tears. And what you need to do is you need to think about what the questions each measure, and therefore can you use that data, that measurement, to answer the research question. Quite often people don't ask the right questions in their questionnaire to get to the research question that the whole project is about. So I'm going to talk about 2 main ways that you can analyse your data quantitatively. So quantitatively means that you're looking at numbers and frequencies. I'm not talking about qualitative analysis. So qualitative analysis is when you're looking at open-ended questions or at interviews. So the 2 ways I'm going to talk about are descriptive statistics. We're talking about means, percentages, frequencies. I'll give you plenty of examples. And sometimes descriptive statistics are enough. You can just use descriptive statistics and that's your results. Sometimes you have to use descriptive statistics along with what we call inferential statistics. Inferential statistics just refers to a stats test where we get a p-value. So a correlation, a t-test, a regression, a chi-squared. So I'm going to give you 3 examples of descriptive statistics and 3 examples of inferential results. The first example of a descriptive statistic I'm going to take from the electric car questionnaire. So we asked a question in that questionnaire, let me go to the questionnaire, which was, do you currently own a car? If we said yes to that question, then we would get a question which said, which kind of car do you own? And you could click the type of car you own. From that question, that one question, we can say that 10% of respondents said they currently own an electric car. And that might be a sentence that goes into your results section. Alternatively, you could do an inferential statistical test on that question along with another question. So that question along with the question, what gender do you identify with? We could take the numbers of people that fall into each of those categories and do a chi-squared test on it. So we're taking the information from 2 questions to do a chi-squared and to come up with a result, a conclusion there. And that's what we would write in our results section. A second example of a descriptive statistic would be if we were just reporting a mean. So in the second survey on academic motivation, there's a whole load of questions which are trying to measure someone's academic motivation. And what we could do is use that measurement across all of the respondents in our questionnaire and calculate this mean, this 3.7, and then report a confidence interval with that, standard deviation with that. So that's us just using one measurement from our questionnaire. But we could take a second measurement from that questionnaire. We asked people in the academic motivation questionnaire if their first language, here we go, do you consider English to be your first language, yes or no? So we can use that question along with the measurement of academic motivation, and we can compare the mean of people whose first language is English with the mean of people whose first language is not English. And we can put that into an inferential stats test, a t-test, and then report the p-value to say whether or not there's a difference. Last example of a descriptive statistic I'm going to take from the salary questionnaire. So we had this question which was about how likely you are to ask for a pay rise. I think it's at the end here. Here we go, this one here. How likely are you to ask for a pay rise in next year on a scale of 1 to 10? And we can take all the respondents who answered that question, and we can say that the mean score for the respondents was 5.5 on that scale of 1 to 10. So that's just taken one question. But if we took that same question about how likely a respondent is to ask for a pay rise, along with the question about age. So I think at the top we asked them, here we go, we asked how old you are. We take those two measurements together and then we do a regression to see if age predicts the pay rise. And then we report it with a p-value there. So you need to think about what question it is that you want to answer, because different analyses will answer different research questions. Now I'm going to look at those descriptive and inferential results again, but this time I've added the questions that they answer, and you'll see how they're different. So going back to the first example of a descriptive statistics, where we said 10% of respondents said they own an electric car, this answers a research question, how many people own an electric car? Whereas if we use the gender question along with the electric car question, then we can say something about whether gender affects the likelihood that someone has an electric car. Again, the descriptive statistic is just going to answer that question, how motivated are the students in the survey? Whereas if we want to say something about there being a difference in terms of motivation between two groups of students, then we need to use another piece of information from our questionnaire. If we just want to know how likely people are to ask for a pay rise, descriptive statistics is enough. But if we want to say something about what affects that likelihood that people will ask for a pay rise, then we need to use another piece of information, another measurement from our survey, and in this case we're using age. So I hope that shows you how we're answering quite different research questions with the descriptive statistics compared to the inferential statistics. The type of data is going to determine the type of statistical test. So it's another thing that people find hard to do, pick the right statistical test. So what's important with questionnaire data is to think about how you're collecting your data. In SPSS, it talks about 3 different types of measure. It talks about nominal, which is categorical data. So in these examples, we have gender, which is nominal. We have type of car, which is nominal. We also have ordinal data. Ordinal data is like nominal because it's categorical data, but it's different because it has an obvious order to it. So the most common type of ordinal data is anything that's on a Likert scale, this sort of strongly agree to strongly disagree scale. And we've got examples of that in the academic motivation survey. We've also got an example in the electric car survey where we've asked people to answer in terms of immediately, 2030, 2040, 2050, or never. They're categories, but they have an obvious order to them. And then we have another type of data, which is scale. So this is sometimes called continuous data or continuous scale data. And it's on a number line. And there's many possible values on that number line. So we ask people to put down their salary. Now we asked the question, what is your exact salary? So people will have written down a whole load of different answers. What we could have done is asked that in an ordinal way and asked people to put their salary into a bracket. And the difference between those, the way we ask the question, will determine the type of statistical test that we do sometimes. Another type of scale is when we take the means of a scale. So we ask a lot of different questions trying to measure something like academic motivation, and then we take the means of several questions. And then the data starts to behave a bit more like scale data rather than Likert, rather than being ordinal data, because it's Likert. Now, if you need to know more about this, that's what the next video is going to talk about.